September 15th, 1943, Dortmund, Germany. The encrypted telegram trembled in Reichsminister Albert Speer's hands as he read the intelligence report that would shatter every assumption Nazi leadership held about American industrial capacity. The numbers couldn't be real. They had to be Allied propaganda designed to demoralize German war planners. Yet the source was impeccable. A German engineer who had worked in Detroit before the war, now feeding intelligence through Swiss contacts, reported production statistics that defied comprehension. Ford's Willow Run plant was completing a B-24 Liberator bomber every 63 minutes. Not every day, not every hour, every 63 minutes, around the clock, 7 days a week. The facility employed 42,000 workers across 3 shifts, consuming more electricity than entire German cities. Speer calculated quickly in his head. If accurate, this single American factory was producing more heavy bombers monthly than Germany's entire aircraft industry. But that was just the beginning of revelations that would fundamentally alter German understanding of their enemy's true power. What Nazi intelligence had dismissed as American boasting was actually systematic understatement of an industrial machine operating beyond European imagination. The transformation had begun on December 7th, 1941, when Japanese bombs fell on Pearl Harbor. Within hours, American industry began a conversion process that would eclipse every previous example of wartime mobilization in human history. Factories that had manufactured automobiles, refrigerators, and washing machines were retooling to produce tanks, aircraft engines, and artillery shells. The scale and speed of this conversion represented something unprecedented in industrial warfare. General Motors, the world's largest automobile manufacturer, ceased civilian car production entirely and transformed its facilities into the backbone of American military production. The corporation's Cadillac division began producing aircraft engines. Chevrolet plants manufactured artillery shells and aircraft components. Buick factories produced aircraft engines and ammunition. Oldsmobile facilities created cannons and small arms. Every major automotive plant across America underwent similar conversions with mechanical precision that stunned international observers. The numbers emerging from American production lines challenged every assumption about industrial limits. By 1943, American factories were operating on schedules that German engineers considered physically impossible. 3 8-hour shifts meant continuous production 24 hours daily. But American plants went further. Many facilities operated with overlapping shifts to eliminate downtime during shift changes. Maintenance occurred during production rather than stopping lines. Quality control happened in parallel with assembly rather than after completion. At Boeing's Seattle facilities, B17 Flying Fortress production reached rates that German aircraft designers declared impossible using conventional methods. The company had revolutionized aircraft manufacturing by breaking complex assembly into standardized components that could be built simultaneously across multiple facilities. Wings manufactured in one plant, fuselages in another, engines in a third, then transported for final assembly. This parallel production approach allowed Boeing to complete heavy bombers faster than Germany could produce fighter aircraft. The psychological impact on German observers was immediate and devastating. Heinrich Nordhoff, a German automotive engineer who had visited American plants before the war, provided reports that Hitler intelligence initially refused to believe. American production methods, Nordhoff reported, represented a fundamental reimagining of manufacturing philosophy. Where German industry emphasized craftsmanship and precision, Americans prioritized speed and volume through systematic simplification. The Ford Motor Company exemplified this approach with production techniques that violated every principle German engineers had learned. Henry Ford's assembly line philosophy, refined over decades of automobile manufacturing, was applied to military production with devastating effectiveness. Complex weapon systems were broken into simple, repetitive tasks that could be performed by workers with minimal training. Quality was achieved through systematic processes rather than individual skill. At the massive River Rouge complex in Michigan, Ford demonstrated the full potential of integrated production. Raw materials entered one end of the facility as iron ore, coal, and sand. Finished military vehicles emerged from the other end. The plant included its own steel mills, foundries, and power generation facilities. This vertical integration eliminated delays and bottlenecks that plagued distributed production systems. German intelligence calculated that River Rouge alone possessed manufacturing capacity exceeding entire sectors of German industry. The standardization revolution that American industry implemented during wartime production represented another shock to German military planners. Where German forces operated dozens of different vehicle types requiring unique parts and maintenance procedures, Americans standardized components across multiple weapon systems. Jeep parts were interchangeable with truck components. Aircraft engines shared common elements with tank power plants. This standardization dramatically reduced production complexity and maintenance requirements. Chrysler Corporation's tank production at the Detroit Arsenal demonstrated American manufacturing innovation applied to armored warfare. The facility, constructed in just 18 months on empty farmland, produced M4 Sherman tanks using automotive assembly techniques. Rather than building each tank individually as German practice dictated, Chrysler created an assembly line where tank hulls moved specialized past workstations. Turrets, engines, transmissions, and weapon systems were installed at dedicated stations by workers trained for specific tasks. The speed of American tank production defied German comprehension. Chrysler's Detroit Arsenal could complete a Sherman tank in less than 8 hours of assembly time. German Panzer production required weeks for comparable vehicles. This disparity wasn't due to superior American engineering, but systematic of mass application production principles that German industry had never fully embraced. Women entering American industrial production represented another revolutionary change that German observers struggled to understand. As American men enlisted in military service, women filled manufacturing roles previously considered impossible for female workers. At aircraft plants across the country, women operated complex machinery, performed precision welding, and assembled intricate electronic systems. The famous Rosie the Riveter became more than propaganda. She represented fundamental changes in American labor utilization that expanded production capacity beyond traditional limits. The Douglas Aircraft Company's production facilities in California employed thousands of women in roles ranging from assembly line work to quality control inspection. These women, many with no previous industrial experience, achieved production rates that matched or exceeded experienced male workers. German military intelligence reports noted this phenomenon with confusion and alarm. The systematic employment of female labor represented a resource multiplier that German industry had never effectively utilized. Night shift production across American industry operated at levels that German planners considered unsustainable. Electric power consumption during overnight hours often exceeded daytime usage as factories maintained continuous operations. The electrical grid infrastructure supporting this production represented another American advantage. Power generation capacity had been systematically expanded to support industrial mobilization, with new plants constructed specifically for wartime manufacturing requirements. The aluminum production revolution exemplified American industrial innovation under wartime pressure. Alcoa and other aluminum producers constructed massive smelting facilities in areas with abundant hydroelectric power. The Grand Coulee Dam in Washington state powered aluminum plants that produced raw material for aircraft production at rates exceeding total German aluminum output. These facilities operated continuously, with electric furnaces consuming enough power to supply major cities while producing strategic materials essential for aircraft manufacturing. American steel production underwent similar expansion and optimization. Integrated steel mills constructed specifically for wartime needs incorporated the latest technological advances in metallurgy and production efficiency. the Gary Works in Indiana, Sparrows Point in Maryland, and other major facilities operated at capacity levels that German steel industry leaders considered impossible to sustain. The quality of American steel, initially questioned by German metallurgists, proved superior in many applications due to advanced refining techniques and quality control processes. By late 1943, German intelligence reports painted a picture of American industrial capacity that challenged fundamental assumptions about economic warfare. The United States was not simply outproducing Germany. It was operating on an entirely different scale of manufacturing capability. Production statistics that German planners had dismissed as propaganda were proving accurate, and the implications were terrifying for Nazi leadership. The realization slowly dawned on German military commanders that they were fighting an enemy whose industrial resources dwarfed their own by margins that made victory mathematically impossible through conventional means. The war had become a contest between German tactical excellence and American industrial supremacy. And the numbers were beginning to tell a story that no amount of battlefield brilliance could overcome. The revelation that would prove most devastating to German morale came through captured American production manuals discovered after the Sicily invasion. These documents, initially dismissed as elaborate deception, contained detailed specifications for manufacturing processes that German engineers spent weeks attempting to understand. The manuals describe production techniques so advanced that German technical experts initially assumed they were fictional. What German analysts discovered in those pages would fundamentally alter their understanding of American manufacturing philosophy. Where German production emphasized individual craftsmanship and quality control through skilled labor, American methods relied on systematic processes that could be executed by workers with minimal training. The implications were staggering. American factories could rapidly train replacement workers to maintain production levels, while German facilities depended on irreplaceable skilled craftsmen. The rubber production crisis that crippled German industry throughout 1943 stood in stark contrast to American synthetic rubber achievements. German chemists had invented synthetic rubber production processes, yet American industry had scaled these techniques to levels that German facilities never approached. The Rubber Reserve Company, established in 1940, had constructed synthetic rubber plants across America with combined capacity exceeding all Axis rubber production by factors of 10. At the Firestone Synthetic Rubber Facility in Akron, Ohio, production lines operated continuously with output rates that German chemical engineers declared impossible using known processes. Intelligence reports indicated that American chemists had refined German synthetic rubber techniques to achieve yields and quality levels that surpassed original German specifications. The Americans had taken German innovation and improved it beyond recognition through systematic application of mass production principles. The shipbuilding revolution occurring in American yards represented perhaps the most visible demonstration of American industrial transformation. Henry Kaiser's Liberty ship program had achieved construction times that maritime experts worldwide considered impossible. Traditional shipbuilding required 6 months to complete vessels of similar size. American yards were launching ships in weeks, with some completed in days rather than months. German naval intelligence tracked American shipping production with growing alarm. U-boat commanders reported encountering more American vessels than their intelligence estimates suggested were possible. The mathematics of submarine warfare depended on sinking ships faster than enemies could build replacements. American shipyards were inverting this equation, producing vessels faster than German submarines could destroy them. The psychological warfare implications of American production capacity extended beyond mere numbers. German soldiers encountering American equipment increasingly reported superior quality alongside overwhelming quantity. American weapon systems demonstrated reliability and precision that matched or exceeded German standards while being produced in volumes that German industry could never achieve. Captured American aircraft revealed technological sophistication that German engineers had not anticipated. The Pratt & Whitney R-2800 engine powering American fighters incorporated metallurgical advances and manufacturing precision that German aircraft designers struggled to replicate. These engines were being produced in quantities that exceeded total German aircraft engine output, while maintaining quality standards that surpassed German specifications. The electronic warfare revolution emerging from American research laboratories represented another dimension of industrial superiority that German scientists were only beginning to comprehend. Radar systems, radio equipment, and electronic navigation devices produced by American electronics manufacturers demonstrated technological advancement combined with production volumes that German electronics industry could not match. At Bell Telephone Laboratories and other research facilities, American scientists were developing electronic warfare capabilities that German technical intelligence was struggling to understand. The systematic application of industrial research and development resources to military problems was producing technological breakthroughs at unprecedented rates. German scientists working individually or in small groups could not compete with American research teams backed by unlimited industrial resources. The ammunition production statistics emerging from American ordnance plants challenged every assumption about sustainable production rates. Lake City Army Ammunition Plant in Missouri was producing small arms ammunition at rates that exceeded total German ammunition output across all calibers. The facility operated continuously with production lines that never stopped, producing millions of rounds daily while maintaining quality standards that met or exceeded military specifications. American artillery shell production demonstrated similar industrial achievement. Plants constructed specifically for ordnance manufacturing were producing artillery ammunition at rates that German artillery commanders could barely comprehend. The systematic application of assembly line techniques to ammunition production had created manufacturing capacity that could sustain artillery bombardments indefinitely without resource constraints. The medical supply production supporting American forces revealed another dimension of industrial mobilization that German military planners had not anticipated. Pharmaceutical companies had rapidly scaled production of essential medicines, surgical supplies, and medical equipment to support global military operations. The quantities of medical supplies reaching American forces exceeded German medical production by margins that made effective treatment of wounded personnel routine rather than exceptional. Penicillin production exemplified American pharmaceutical industry capabilities. This revolutionary antibiotic, discovered by British scientists but developed for mass production by American companies, was being manufactured in quantities sufficient to treat all Allied wounded personnel. German medical services had no comparable capability, forcing German military medicine to rely on traditional treatments while Americans employed revolutionary medical advances. The logistics revolution supporting American global military operations represented the culmination of industrial transformation. The complexity of supplying military forces across multiple theaters of operation required coordination and planning capabilities that exceeded any previous military undertaking. American industry had proven capable not only of producing required materials, but of delivering them anywhere in the world on schedule. Transport aircraft production supporting global logistics demonstrated American manufacturing versatility. Companies that had never built aircraft before the war were producing cargo planes and transporters using helicopter techniques adapted from other industries. The Douglas C-54 transport aircraft was being manufactured at rates that enabled global airlift capabilities previously considered impossible. German military leaders reviewing these intelligence reports faced an unavoidable conclusion. They were fighting an enemy whose industrial resources exceeded their own by margins that made conventional victory impossible. The war had evolved beyond tactical excellence versus numerical superiority. American industry had achieved systematic dominance across every category of military production while maintaining quality standards that matched or exceeded German achievements. The implications were clear and terrifying. Germany's only hope for victory required preventing American industrial capacity from reaching full potential. By late 1943, that window of opportunity was rapidly closing as American production lines achieved peak efficiency and output levels that would sustain global warfare indefinitely. So, the encrypted telegram that trembled in Albert Speer's hands that September morning contained more than production statistics. It contained the mathematical proof of German defeat. Every number, every factory report, every intelligence assessment pointed to the same inescapable truth. America had not merely mobilized for war, it had fundamentally reimagined what industrial warfare could achieve. The shock experienced by German observers went beyond simple numerical superiority. They were witnessing the birth of modern industrial warfare, where victory belonged not to the most skilled craftsmen or brilliant engineers, but to the nation that could systematically organize human and material resources on an unprecedented scale. American factories operating around the clock, women wielding precision tools, assembly lines producing complex weapon systems, synthetic rubber plants outperforming German innovation. These weren't just production achievements. They were demonstrations of a completely different approach to national mobilization. German military excellence, legendary engineering precision, and tactical brilliance had encountered something they could not overcome. American industrial democracy had proven capable of achievements that German planners had considered theoretically impossible. The war would continue for 2 more years, but the outcome was already written in the production statistics flowing from American factories every single day. The revelation that would haunt German leadership until the war's end was simple yet devastating. They had challenged not just American military forces, but American industrial civilization itself. And that civilization had responded with capabilities that rendered German resistance mathematically futile.